welcome everybody. Thank you very much for taking the time out to come and learn a bit of what we do in this industry and how it comes together. My name's Nathan Broughton. I've been a binder and finisher for 25 years. The last 5 years, I guess, has been a bit of a learning curve for me as well, moving from an offset world into learning how to overcome challenges with digital. Digital print originally was fairly ordinary in quality, but the continual growth and improvement in digital print is just outstanding. The difficulties then are faced in the bindery or the finishing area, where the digital print engines throw challenges to us that we haven't really experienced before. We have in certain pockets of offset printing, but one of the biggest challenges is cracking of paper. So I can ask you guys and girls around the table if you experience cracking, but I already know the answer. If you have digital print, you experience cracking. So there are certain ways and means to overcome those kind of issues, and I'd like to discuss them today. I'll try and keep it fairly informal. I've got a lot of samples on the table we can discuss and look at and explain why and how they've gone from being poor quality to good quality. Basically, this is the formal part of the presentation, so I want to explain a few things to you, and some of the things you'll know more than me, like the market conditions. My opinion is that everyone knows the market conditions, competition is fierce. To me, quality, price and service win out always, and usually from my world, being a hands-on guy on the machines, it's quality. It's the number one factor. You always hear the comment, we need it now, but the customers always have time for a reprint. If we get it right, we do it once, the customers are happy. So that's about my input for the market conditions. You guys run businesses and girls run businesses, you know more than I do about that. To me, the technical challenges are very, very important. The technical challenges in quality can impact the profitability of a company, and semi-skilled multitasking people is always going to be a challenge, especially in the finishing area. There's basically a global shortage of bookbinders and finishers. When I went to technical college 25 years ago, we had the most enrolled ever in Sydney TAFE, and there were 60 of us. Compared to printers, there was hundreds. And my ratio that I usually worked on in the offset world was 2 printers, 1 binder. So you can do the sums and realise how much of a shortage there is in finishing. A lot of the customers have the opinion of how hard is it to fold a piece of paper. Why is my job cracking? It can't be that hard. And it's not hard to fold paper. It's hard to fold paper consistent with quality and speed and get it out on time. But it's not difficult if you invest in the right technology. Business challenges. To me, if we remove the technical challenges of manufacturing, it allows you people to focus on your business and do the selling and the investment that you need to do. So we'll look at the technology, how to eliminate paper cracking, how to what processes appear to be eliminating but can actually, on some stocks, reduce the cracking, on some jobs can encourage cracking in the same process. So we'll have a look at why and how that happens. We'll look at where the technology is applied, and give you a few things to think about when you look at, do you go inline or nearline with your finishing. So Neil at the back there threw this quote together from a magazine that sort of grabbed my attention. The way I interpret this quote is that the quality from your company to your customer is ultimately determined by the final process. So even if you print at the highest quality on the best stock, on the best machine, everyone likes to say they've got the best machine or would like to have the best machine, all this can be ruined if the finishing's not right. So as digital print engines get faster, get more and more quality. They're always improving. We need to look at ways to show the quality of that print in the finishing, so that the finishing doesn't detract from the final product. So there's new methods of printing required finishing techniques to overcome post-print challenges. Some of the challenges that we face in the bindery or finishing area: curling paper, image cracking, static. Everyone wants to reduce wastage and increase efficiencies and save costs. So basically, the curling, the image cracking, and the static are all problems faced by finishers after the printing process. The reason for those is that the way the print, the way the ink or the toner is applied to the paper on digital print engines removes the moisture out of the paper, and that encourages the paper to crack, just like a dried out piece of wood. The curling of the paper is also as a result of the temperature running through the machine, which causes the paper to curl. And any finishing process that has to take on a challenge of curling paper depends on the feeder, how well the feeder's been developed, on how you can overcome that. Something that stands out to mind with that is if you wanted to laminate a job two sides with a cellulose, and you only had a one-sided celluloseing machine, you run it through, and it curls with the laminate because it heats up. When you try and put it through the second side, it's very difficult to get the sheets through. So there's lots of different ways to approach and attack those challenges, and we'll go through some of them as we go on. So I touched on that. So curling stock, high toner, fusion temperatures can cause the stock to curl. So basically, you can see it if you put a piece of paper anywhere near a warm surface, it starts to curl. It's just the moisture reducing out of the paper, which makes the stock difficult to feed. If you get a sheet, these are obviously a lot more curly than you'd like to see trying to go through your finishing machines, but the machine has to be able to cope with a certain amount of curl and still be able to feed consistently. Special techniques such as low pressure suction to hold a substrate, accurate sheet alignment. So the manufacturers are getting better and better at being able to build a quality feeding system on a low cost investment machine. With the accurate sheet alignment, that takes us back to traditional processes of printing and finishing. Basically, if you don't get your sheet exactly square to the first roller, it won't fold straight, it won't crease straight. When you get the job out, it's out of square. Tolerances that we're used to working with in the offset world are less than 0.5 millimetre. So digital seems to, the stocks are heavier. The heavier the stocks, you can tend to get a little bit of acceptance in movement, but not very much. So it's all about the alignment into the machine, and some of the higher end manufacturers are now running with a ball and rail side lay, which is the traditional way to align a sheet into the machine. So cracking and toner, cracking of ink and toner I should say, the crease ensures the ink toner is embedded in the fibre stocks. So you'll notice the difference in terminologies here. We're talking about scoring and we're talking about creasing. So they get mixed up when people are talking in the industry. Basically, the difference is a score is a result of a sheet passing through a rotary disc that has a male and female action. So basically, if I pass this sheet of paper through a machine and have a steel disc that goes like that, you can see straight away we start to create a form of a crease. So we bring those tools in tighter and we create a score. Creasing is quite different. Creasing is a male and female matrix where the sheet stops and a male matrix comes into a female matrix and it embeds the toner into the paper, or the ink into the paper. So this is a little bit difficult to see. Here that you can see a little bit of cracking, here you can see no cracking. So this is a traditional score process which you'd see on a traditional offset folding machine. And some of the some of the basic systems of digital finishing, and this is a proper male and female matrix crease, and the male and female matrix crease comes from old traditional processes. So if we can continue on there now. Static is another issue, which was more prevalent in the earlier machines. I think it still is a reasonable issue to be dealt with. Basically, when the first digital print machines came out, you could pick up one sheet and you'd have all those sheets stuck to it. It was a real challenge for finishing, and most printers look at their jobs and say it's printed, it should be at the door. So you win or lose in the bindery or the finishing area, I believe. So the ways that you need to view a machine when you look at these issues and these challenges is what have the manufacturers done to overcome these issues. Basically, there's really only three issues, and we've put them up there: static, cracking, and quality of the job going out. So when you look at a machine like this, you can see that they've put a lot of emphasis in the feeder system to aerate the paper, to remove the static, make the paper float so that the bottom sheet pulls down and feeds. That also helps them with the curling. They make the sheets float and the bottom sheets get pulled down. So if we can go to the next slide now. So this we'll sort of go back a little bit to talk about creasing again against scoring. So there's some samples over there if you guys can have a look and pass them around. Basically, the ones that are cracked have not been creased, and the ones that aren't cracked have been creased. The machine downstairs, all I did was turn the crease off and ran 10 or so, turn the crease on and ran 10 or so. So you can see the difference in the result there. When we look at creasing against scoring, as the paper passes through this process, you've got a score wheel that forces its way into the paper, and on some jobs it will reduce the cracking. Other jobs, the force of that will actually break the fibre of the paper. And so when you get a coated stock, sometimes when you score the job and fold it in half, you look at it and it looks like it's two different bits of paper stuck together. One's snapped and one's not. So that's the result of trying to fold paper that's been scored compared to creased. We can continue on, Neil. So this, going back to traditional methods, this is the best way to crease a sheet of paper to eliminate cracking. So this has gone back to 1950s. So what some of the companies have done, Morgana in particular, is they've focused on taking that technology and putting it into equipment that's easy to use and easy to set up. The skill level to run a machine like that is high, that you need a dedicated person to operate equipment like that, and you also need to provide the people with overs. So if I was a production manager in a traditional offset finishing area, and I wanted to crease and fold some 250 gram job, I'd give it to the guy and I'd give him probably 200 overs, and I wouldn't even consider that was any kind of issue. If you say 250 or 200 overs to a digital printer, and the look of disgust on their face is quite surprising. So generally in the digital print area, from what I see, people like to work on an average of maybe 10 to 20 overs on the job. So what some of the manufacturers have done is taken the process of male and female matrix creasing, put it together with a computer system, and developed a way for the operators to just select simple things. There's about 4 things that you adjust on this machine in particular to produce a job. So what they've done is taken the smarts out of the operators, put them into basic computers, and allowed anybody to be trained and operate that machine. Basically, a machine like this, we can train anybody in this room in half a day to be self-sufficient on that machine. Doesn't mean that you know all about it, doesn't mean that you're never going to have a problem, but you'll be able to produce a job, we'll be able to walk out of that factory and you'll be producing jobs. It's really that simple. And you will have already seen that in the digital print engines that you've bought compared to the traditional offset printing machines that take up a lot of space, need a lot of skill. So this is a picture of the creasing matrix and how it works. Basically, Morgana in particular have taken their whole business unit and focused on that one thing. So through the whole range of their equipment is that crease. It doesn't matter whether you're creasing by hand, at how fast you can do that and put a sheet in, and maybe 50 in half an hour, up to 6,000 an hour, it's the same crease. So the quality speaks for itself when you look at things that are on the tables. Basically, there's some here that were finished on the devices downstairs inline, and then I've taken them, flattened them out, and run them through and put a crease in them. You can hand fold that crease if you like. So, so it all really comes down to that crease. So then the next part of the process is folding. When we look at how to fold paper, traditional processes allow me to run that sheet through a machine. It dries up, hits a stop, and impacts and forces that fold down into the rollers. That's how we fold paper. That can create cracking in itself, even if it's creased the proper way. So, what Morgana have done, they've patented this knife system where the paper passes through the rollers. A sensor says, yes, I've seen it. It passes through, it says, okay, at 210 crease. So it creases, the paper continues. It says at 210 fold, and a piece of metal, the flying knife they call it, comes through, pushes that crease and puts it into transport rollers. So there's a zero impact on the paper. So that this knife actions the sheet into the rollers, and the rollers transport the paper away, and that's why this particular machine doesn't crack the paper. So these things here, you guys and girls have heard this plenty of times. Improved turnaround times. It must be simple to use. Bring the work back in-house. No need for careers or lost time, less wastage and spoils. Basically, to look at a way to produce short-run digital print, it has to be smart, it has to be fast, and it has to be easy to use. Those things will take care of themselves. So I touched on that. No need for specialist bindery staff. As I said, there's a global shortage of bindery staff. Lower cost of training, also lower cost of operating. If you have to employ a tradesman to fold paper compared to somebody that's fresh out of school, or somebody that's anybody in the factory, you could literally take anybody in the factory and have them produce a job. And this is a good point actually. It's common to see one operator for both print and finishing. That doesn't happen in offset. In maybe some of the smaller shops, yeah, because it's a need to happen. When you go downstairs, the machines are ticking over. The guys can be over on the guillotine cutting, or over on the digifold folding, and it's all one process being operated by one person, maybe two people. At print engines without the need for further investment in finishing. So if you look at an offline solution, there's pros and cons of everything. When we look at inline solutions, some of them you can booklet make, you can fold, you can do all sorts of things. We can pre-crease the covers before we put them in your booklet makers inline, so you remove the cracking, you still produce inline. You have to look at your business mix on how to take a particular job and process it, and does it slow your machine down, does it meet the output as advertised. So yeah, so wherever the digital printer, there's a need to crease and fold, brochures and flyers, creasing the covers. And these machines can also be used for traditional printed work. So you could have one machine that's doing a lot of stuff. We've got customers, one of the biggest bookbinders in Australia, Marble Bookbinding, bought this to have a solution for the digital market, and then realised running their traditional saddle stitched books, oh, that job's cracking the way we do it. So they wheel this machine over, plug it into the wall, put it through that machine, and put it through that machine. It's literally that good. Yeah, I think we've touched on all that. So basically, do you have any questions?
We have the auto creaser,
yep.
and we feed it through face down or face up. But is there a more correct way of, should it be like the male side out or in, or does it really matter?
Yes, there is. So basically the rule of thumb that I use is that if it's below 150 grams is about the cut-off, so it's below 150 and below, I fold with the crease. If it's above, I fold against the crease. So so the way that works, if I can just jump behind you with the board here, sorry to disrupt everybody, but what we find is most digital print is sort of 200 gram and up. So if we look at the crease, so that's the crease of your cover. Most people think we should be folding on the centre. The way these creases work is you should be folding either here or here. That's the weakest part of the paper. So what happens is people say, okay, I'm going to fold exactly at 210. I've got 210 here, I've got 210 here. I'm going to fold exactly at 210, it's going to come in half. And then when they fold, the fold moves a little bit up and down, up and down, up and down. They need to be aiming for one side or the other. And that's where the flying knife comes in. It'll find its spot, and in the settings of the machine, it'll actually automatically offset that fold by about 0.3 of a millimetre in the settings of the machine. So we'll crease at 210 and we'll fold at 209.7 or 209.8 to hit the edge of that crease. So if you're doing, say, a variable data job, and you say, well, I don't want to turn my paper over because I'm running in the wrong order, you can turn the crease over. You can take the crease out, turn it over, and run upside down.
How does grain direction of paper stock factor in?
So grain direction is a big factor when you're rotary scoring. When you're creasing with these machines, it's not an issue.
That machine does A3s as well, or is it only an A4 machine?
A3, so it can go up to 900 long by 385 wide.
Okay, so we've got 6,000 A4 sheets, there was an A4 machine, it's an A3.
Yeah,
So, yeah.
All the manufacturers, it's like Holden saying they've got the fastest ute in the world. Yes, it is, but it's not only the fastest ute, it's also another thing. So, so they rate the machine at an A4 sheet, so I think that's a fairly standard size for everybody. When we go to a longer sheet, it takes longer to process the paper. So it's just a guide on the speed of the machine. From what I understand, it's the fastest. I don't know if it still is. Yes.
What's the smallest it can crease?
Smallest? DL. So,
and you can fit a perfing wheel?
yeah, so you can attach a perfing wheel to the machine. Basically, this machine here, it can crease only, it can fold only, it can crease and fold, or it can perforate. So if we were to perforate the sheet, it perforates in the running direction of the machine, so you can't crease and perforate in the same process in the same direction. You would run it through, turn it, and run through.
That's annoying.
It is. There's some development, I believe, to address that issue, but I don't think it's ready yet. There's also there's a lot of different machines in the Morgana range, as I spoke about before. There's all the way from hand creasing up to this. There's also PUR binders and booklet makers and all sorts of things, card cutters. So so when we look at the cracking and the folding, basically it's a machine per budget. So if you've got a little place that does a little bit of folding and you want a hand crease, that's fine. You can spend around just under $2,000 and get a little hand crease. That's exactly the same crease as what's in that, and it just goes by how much you produce. So if you do 200, your average runs at 200, you might want a hand-fed one. If you do jobs that are 1,000 on average, then you move up to there's a creasing unit without folding, so you can take it in an investment stage and add a folder later. There's all sorts of ways you can do it.